Welcome, welcome everyone to a packed house to the second day of the 8th day Hamptons Documentary Film Festival. We've been around for about 18 years. This is our celebration. Thank you. I'm Jackie LaFaro, and I'm very happy to introduce an award-winning film, A Life Illuminated, receiving the Nancy Nagle Kelley Environmental Award. This inspiring film follows the extraordinary exploits of Dr. Edie Widder and her study of deep-sea bioluminescence. And we are very fortunate tonight to have Dr. Widder with us tonight to accept the award and on behalf of Tasha Van Zandt, who couldn't be here, the filmmaker, and to have a post-screening conversation with our very own Carl Safina. Let me introduce Chris Kelley, whose law firm, along with the Kelley family, are paying tribute to Nancy Nagle Kelley, former director of the Nature Conservancy here on the East End. Nancy's work to preserve our waters and precious open spaces is deserving of this named award. So let me introduce Chris Kelley and Claudia Pilato, and they want to say a few words before they present the award.
Hi, everybody. I'd like to thank Jackie and Claudia for coming up with this great idea and honoring Nancy for her work. We really appreciate it. And also want to thank Claudia in particular for putting up with my family and their negligence in ordering tickets and keeping the herding cats. We're here tonight to honor my wife, who, like I said, made a career and a passion out of preserving both terrestrial and marine ecosystems. And that was her life, and she did it very well, and she's well deserved of being recognized for it. So thank you, Claudia. We're going to see something about biodiversity tonight. I'm sure we're going to love this movie.
Thanks all of you for being here. Nancy was a dear and brilliant friend who cared so much about the environment and advocated it for it every day. She was an avid reader and an avid film goer. And we're so really pleased to be able to present the first Nancy Nagle Kelley Environmental Award to Tasha Van Zandt for Life Illuminated. And here is Dr. Edie Widder to accept the award. Thank you so much.
This is such an honor. I wish Tasha could be here. She deserves this so much. And I'm just thrilled by the response to this film. She is just a consummate storyteller, a wonderful environmentalist, and an amazing person. And I thank you on her behalf.
Hello, everybody. Okay, so I have comments, I have questions. How much time do we have for this?
You have about 15 minutes.
Oh, boy. Okay, first of all, fantastic, right? And just from a sheer storytelling perspective, I thought the approach was extremely impressive. And before I have some questions for you, Edie, I have a question for the audience. Actually, only part of the audience, actually only the men, because the women wouldn't know the answer to this question. And here goes. The scene where Edie comes up and the sub was flooded, and she goes down an hour later. How many of you men would have the balls to do that? Okay, so you've had quite a life. You've brought us to a planet we should know something about, that we are strangers to our own home, really, right? And I'm sure that's one of the points. One of the things about a life like yours and your work is it takes an unbelievable amount of drive and persistence. Do you think of yourself that way, or can you just do it because you just do it?
I think the drive for me is the curiosity. Just I mean, I think we're all explorers, and it's in us. And then once you get the taste for that, it's just hard to give it up. But yeah, I just wanted to know more about the planet I live on from a very early age, and I've always felt that drive.
I have another, it's sort of, I guess, technical sort of questions. One is, it's unbelievably expensive to do that work. Those ships are really incredible. Who runs those ships, and where does all that funding come from, and how does that work, and how does that fit into the current catastrophe in this country?
So the funding is for deep sea exploration has always been an incredibly tiny fraction of what we've spent on space exploration. I mean, absurdly tiny. But it has come from National Science Foundation, National Oceanographic and Atmospheric Administration, and the Office of Naval Research. And I got a lot of my funding from the Office of Naval Research because they had a very strong interest in the fact that bioluminescence could reveal large cigar-shaped objects moving through the water at night. And so they just wanted a basic understanding of how that happened and what kind of predictive capability they might be able to have for it. Mm-hmm. And there's been funding from other sources. There's a great deal of interest in bioluminescence because of the capabilities it's made available for cell biology. So it's basically lit up the inner workings of cells with the chemicals that have been extracted from different bioluminescent organisms. And so there has been some funding that's come from that kind of research as well.
Exactly how does that work, that they light up other cells with the chemicals?
Well, the most famous example is what's called green fluorescent protein that came from a bioluminescent jellyfish. And it can be cloned into the DNA of an organism or a cell line. And when the DNA gets turned on, the cell becomes competent to be fluorescent. But there is other bioluminescent chemicals that have been extracted that have been used to, for example, see how muscle cells worked, where the calcium came from, and how it was activated. All of these things there's just been one discovery after another based on bioluminescent research.
So watching the flashes, I would presume that there's energy involved in the flashing, and that may be wrong because there's
definitely
chemicals. So how are the chemicals recycled, and why don't they get tired, or do they get tired? Or
they do get tired, and that was part of what it shows at the that business of the first couple of times we tried. We had the white lights on first, and that had exhausted it. And you have to be in the dark, and you either have to enter the water in darkness or sit there for a very long time before it becomes competent to do the flashback. My hypothesis, which we don't cover in the film because it's definitely getting into the scientific weeds, but I think what you're seeing there is bioluminescent bacteria that they require oxygen in order to bioluminesce, and in fecal pellets and marine snow, the snow flocks, there's actually an oxygen gradient that develops, and there's no oxygen in the center of the flock, but there's cyanobacteria, and if you flash a light at cyanobacteria, it produces oxygen, the basis for life on Earth.
Wait, it produces oxygen if you flash a light at them?
Yeah, that's what photosynthesis is. Photosynthesis is the production of oxygen in response to light. We just take it for granted because it's going on all the time.
Okay, well, we don't have time for the chemistry questions, but it's not the way I understand photosynthesis, but okay. I will talk to you later about that.
I'll be glad to give you a little...
Oh, you know more than I do about that, I'm sure. So you said the marine snow is bioluminescent, but it's not alive technically.
No, it is. It's got bioluminescent bacteria.
But the bacteria in it are what are bioluminescing.
That is correct.
Okay, so that was one of my questions. And why is there so much bioluminescence on Earth? What is the purpose of it? What's the purpose of it we see it in very shallow water. I mean, it's all over the beach here. You just step in the water. If there's a new moon, there's plenty of it. What's it all doing? And there are bioluminescent mushrooms. And what are they doing? And why would mushrooms light up in the forest at night?
So the reason there's so much bioluminescence in the ocean compared to on land, and I mean it's incredible, it's dominant in the ocean, is because as the ocean filled up with ever swifter and nastier predators, prey either had to evolve to outswim those predators to survive, or they had to figure out a way to hide. There's no hiding places in the open ocean. There's no trees or bushes to hide behind. The only way to hide is to go down into the dark depths. And so a lot of animals were driven into the dark depths, but the thing is that the food was being produced at the surface where photosynthesis occurs. And so every day on this planet, there's this massive migration called vertical migration, where the animals go down and hide in the dark depths during the day, and then they come up and feed in food-rich surface waters under cover of darkness at night. But they spend their lives on the edge of darkness because of that. And so selection pressure was to get more sensitive eyes and enhance visual signaling. So you could imagine this situation where an animal, fish, raised its opercula to show spots on the opercula to attract a mate. And as they got darker and into the darker depths, that wasn't very, very good. So the selection pressure was then to make those more visible, first by making them reflective, and then by creating the bioluminescent chemicals that produce that light. That was a hypothesis for a long time, but we actually managed to prove it remarkably, because you can't prove much in evolution, but we captured an octopus that was hanging out in the water. This was in the Gulf of Maine. And it was hanging upside down, like an upside-down umbrella, because it had webbing between the arms. Brought it up into the lab, and I was photographing it in a tank in the lab, and my postdoc at the time leaned over my shoulder, and he said, those don't look much like suckers. They look more like light organs. And so we both thought so, and so we grabbed it, took it into a dark room, and sure enough, they lit up. And when we later dissected it, we discovered the vestigial muscle rings. So it was evolution caught in the act. It was these were suckers turning into light organs. So for some reason, at some point, this octopus got driven out into the open ocean environment, where its suckers were no longer useful for hanging onto things on the bottom, but they were useful for something that an octopus uses its suckers for, which is to attract a mate. They'll throw their arms up over their heads to show off their suckers. It's like a wet T-shirt contest. See what I got.
I didn't think we were going there during this. I have one last question, then we'll see if any of the people in the audience have some questions. So think of some good questions. But I've been out with Bruce a few times out of Moss Landing, where we used ROVs. And, it's a lot safer, it's a lot cheaper. But how does that compare to the experience of being in a submersible yourself?
So my problem with remote operated vehicles is they use bright white lights almost for the longest time, because their cameras weren't sensitive enough for anything else. And they have very loud, noisy thrusters. And then when you're working with an ROV, you're just seeing whatever their cameras see, which is kind of like looking through down a tunnel, down a tube, compared to when you're sitting in a submersible that is completely transparent and you're there in the middle of the everything that's going on. There's so many times that I've spotted something just out of the corner of my eye that, then you turn the sub and you can see some amazing action. But remote operated vehicles are not anything like what the submersible experience is like.
Okay, so it's like the difference between night and day, except it's night.
Exactly.
Okay, any questions? Yes.
So Tasha Van Zandt found me. So when I got the first imagery of the giant squid, she got interested in the work I was doing, and I think that was the story she was thinking of telling. And she contacted me, and it was kind of a long process because it required building up trust. I had cinematographers and documentarians on some of my expeditions, but this was going to be different because this was. It took her a while to convince me that this was going to be about me, and not. I kept telling her. So our biggest argument was the title of the documentary, because I wanted to call it Life Illuminated, and she wanted to call it A Life Illuminated, and that was the difference in our view.
Actually was thinking about that. Any other questions? Yes.
Hang on. Fabulous film, amazing work. Thank you so much. A couple of years ago, there was a troubling documentary at the festival about deep sea mining.
Mm-hmm.
Is what you're revealing about all the life in those places that they keep saying are dead, can that help argue against the possibility of that continuing?
Oh, I hope so, and that's definitely a goal. But it's been an incredibly difficult story to tell when I couldn't even film it for a very long time. The flashback is, in particular, I think, is so important, and it was a very bizarre set of circumstances that came together to allow us to get that footage, and it was a 2-day window, and nothing ever works at sea. I mean, it was just incredible that everything had to happen on that last day, and it did.
Yes, sir.
Can you wait for the mic? Could you post this? Who is it?
He's got a very
Oops, here, the other one?
Thank you for this. This is quite remarkable. What is the status of marine biology as an education versus employment afterwards? Because I've gone on some of these ships, and when you talk to the PhD, postdoc biologists, a lot of them say it's one grant, and then you're back home struggling to find another grant. So I was just curious, you've become very successful. You must have a lot of very jealous peers, because to get to this status, it seems very unique and minuscule from what I've heard about actual employment as a biologist, as a marine biologist.
Well, I think that it's not going to be minuscule by any means, because monitoring the health of the planet is going to be determinant of our survival on the planet. And we are an ocean planet. So there's no question that we're going to need these people. Right now, with cutbacks on NOAA funding and funding in general, it's grim. There's no question that it's grim. But the drivers are there, and you have wealthy people like Ray Dalio coming along and creating Ocean X and he made the ship and submersibles available to us. I mean, we had 2 subs. That's why they were able to get that astonishing footage. So there is hope.
We're out of time, unfortunately. I just want to add a little frosting on that answer. There are actually thousands of people who work as marine biologists or oceanographers. They're professors of marine biology, oceanography, atmospheric chemistry that has to do with oceans and currents and things like that. So it's less minuscule than you think, and it's less like being a jazz musician than you described. I know something about both. But what is happening now with these catastrophic cuts has put some of our colleagues out of work. I just was I'm at the Marine Department at Stony Brook, and somebody came to visit who I haven't seen in a few years, just today, and she had lost her job just a couple of months ago, just like that, just one day, just like that. So you know, this country has a huge footprint in science around the world, so it's not just confined here, what's happening. And hopefully that will change, hopefully. But it's easier to destroy things than it is to build them. I'm sorry that we're out of time. I thank you all very much for coming. Thank you, Edie, for your entire life and all your work and bringing us to our home planet.